Hello everybody. In this video we are going to look at an example of using an abstract class. So here I have a class called shape, okay, and by adding the keyword abstract I have made this a abstract class. Now the class shape has got two data members, regular data members of its own, called dimension1 and dimension2, and it has two methods, get dimension1 and get dimension2. So these are non-abstract methods, and these dimension1 and dimension2 are data members. Along with that, shape also has a constructor, two argument constructor, and then it has one method called area, which is also an abstract method. So the abstract class shape now has two data members, two regular methods, one constructor, and one abstract method called area. So you can note here that the method area has the keyword abstract assigned to it, and you can see we don't have a body for this particular method. So this is an abstract method. Now this abstract class must act as a superclass in an inheritance hierarchy. So we create two classes here, rectangle and triangle. Rectangle and triangle. So in the rectangle class we see class rectangle extends shape. Now you can see that rectangle class is not an abstract class, it's a concrete class because we don't have the keyword abstract here. And you can see it has a constructor, and the constructor, what it does is that it calls the superclass constructor. That means it calls the constructor of the shape class. And what it does here is that it overrides the abstract method area, which is defined in the superclass, and it gives its own implementation. So area for a rectangle would be dimension1 into dimension2. So in this, for a rectangle, dimension1 may be the length and dimension2 may be the breadth. So you can see in the abstract class we have not given any definition or any body to the method area, but in the subclass we have given an implementation for it. Similarly, in another subclass of shape, triangle, okay, same way in the constructor we are calling the superclass constructor, and we are overriding the area method. So we are giving an implementation to the area method of the superclass. So here we are returning the area. Area of a triangle would be 1 by 2 into dimension1 here would be the height, and dimension2 would be the base. So in a triangle, area of a triangle is 1 by 2 into base into height. So it is returning the area. And in the main function, inside another class, test abstract, we have, just ignore this statement for now. You can see we have a rectangle object R with two dimensions given as 10 and 20, and triangle T with two dimensions as 5 and 10. And here what we are doing, we are printing the value. So we are printing like this, the area of the rectangle with length. Now R dot get dimension1. So get dimension1, this method is declared in its implementation is given in the superclass shape. So it is calling this method. So rectangle class has not overridden this method. It is just getting it from the superclass, that is shape. Similarly, for breadth, it is taking R dot get dimension2. So this also it is getting from the superclass. And finally, R dot area. So because area in the superclass is an abstract class, is the abstract method, so the implementation of area in the class rectangle is called, because R here is an object of the rectangle class. Same manner we are calling now, we are printing the area of the triangle with height is dimension T dot get dimension1, and base is T dot get dimension2, and the area is T dot area. So now the area method of the triangle class gets executed. compile this and see. Let's go to the command prompt. Let's compile this. Okay, correct. Let's run this. So you can see that it's printing that the area of the rectangle with length 10 and breadth 20 is 200. Area of the triangle with height 5 and base 10 is 25.0. So in our program, okay, because we have assigned these values to dimension 1, dimension 2, so it's working in this manner. So as you can see out here, we have initialized this dimension 1, dimension 2 to 10 and 20, and again 5 and 10. So this is how an abstract class works. Now remember one more thing. For an abstract class, we cannot create an object. So if I try to create an object for this abstract class like this, shape S is new shape. Okay, let me give some values here, 20 and 30. Okay, 20 and 20. Now let me try and execute this. First, let's try to compile. So there itself it will tell you shape is abstract, cannot be instantiated. So you cannot create an object of the shape class. Then we have, let's look at this program once again. So I cannot have this, so I'll just remove it. I cannot create this. Now what happens if I don't give an implementation for area here in this subclass? So in rectangle class, I have just commented out the implementation for area. So let's see what happens. Okay. So we'll compile. Okay, so there you can see there is an error. What does it say? Rectangle is not abstract and does not override abstract method area in shape. So because rectangle class is not an abstract class and it does not override the area method of shape, so it will give you an error. So the subclass must always implement or must always override the abstract method defined in the superclass. Now this would not have been this error would not have occurred if suppose rectangle was a superclass itself. So I may have something like shape, then I have a subclass rectangle, and then another subclass from rectangle, say filled in rectangle. Okay, so in that case, if rectangle doesn't give an implementation for area, then it is expected that the filled in rectangle, that is the subclass of rectangle, will give the implementation. So somewhere in the inheritance hierarchy, there has to be a overriding method for an abstract method. So that is about your abstract method.